Welcome back, everyone, to Merge Conflict, the one episode in which Frank and James are in separate locations and also different locations. We're always in separate locations, but we're not always in, well, technically we're in separate locations and different locations, but we're in different locations from our normal locations, which are separate locations from each other.
Woo.
Saved
We
it.
did. We bravo. We did record together the one time. Remember, neither of us knew what to do. I just stared directly into your eyes to show dominance, and that didn't work. And so I wasn't sure what to do when we were in the room together. So it's better that we're in as far apart in the world as we can be.
Yeah.
We should measure distances and just
Yeah.
try to maximize it.
Well, reflecting back on that episode, if you will, it was quite glorious. And yes, I think that sounds like a great experience for you, getting to stare deeply into my eyes and into my souls. Many people would like to do that, but you, Frank Krueger, had the option. We actually, literally, though, did get to hang out with each other. We had our annual Let's Hang Out in Seattle once a year, and we had fun. We drank some wine and we ate some cheese and ate some frozen pizza with my wife, and that was fantastic. So thanks for making a trip across the bridge, and by bridge I mean the Puget Sound. So
yeah, I was gonna say I crossed the Strait of Juan de Fuca. I get a little more credit than that. I bared the Deception Pass. There's some big trees out there, those big scary trees. But yeah, it was a delight. James and I got to actually see each other. It doesn't happen as often as you would think for living in the same hemisphere and all that stuff. Mostly
yes.
my fault, but it's always a delight. It was wonderful to see you, James. And what says friends more than frozen pizza? That is the perfect way of saying
That's
friendship.
correct. And it was from PCC, which means it's like a $18 pizza. So it's perfect.
Of course.
Yes. Okay. Well, let's reflect on System.Reflection and maybe emit. There's a lot of things happening in the world of .NET and the world of .NET 8, as we've talked about on the pod. We've had a few episodes already specifically on pieces of technology that we're all too familiar with in the world of Xamarin and .NET MAUI and, Android and iOS things, which is ahead of time compilation, or AOT. And AOT specifically, native AOT, not that other AOT. This is the native one, Frank.
Trademark register.
It's in this one's in the box. This one's a boom. It's a native. This one specifically has been around for a bit, and in .NET 7 started shipping out by enabling console applications to be native AOT compiled. The advantages of AOT compilation, of course, is that you get ideally faster startup, faster code, and hopefully smaller executables. Not always, but ideally that's the use case that we would like to have. But with that comes different limitations. Hence, when native AOT was first unraveled and unveiled into the world, if you will, it was just console apps. Now, since then, in .NET 8, there was many more supports added. The biggest one being official support for ASP.NET Core web APIs. And if you know anything about web APIs with ASP.NET Core, they power a lot of stuff, like Bing Copilot, like chats and GitHub Copilots, and everything that is on the internet is powered by an ASP.NET Core web API. They're really fast.
Every
really
website
awesome.
I've ever made.
Yes, they're all APIs built with .NET. If the front end's, even if the front end's not .NET, the back end probably is. So I think that was a huge step forward. And additionally, with that came some additional support for Mac OS support and desktop applications, with an additional a bunch of experimental support, which we've talked about on the pod for iOS and tvOS and Mac Catalyst and even Android applications. And while there has been AOT on those platforms with a built-in mono AOT support that has been around for a long, long time in the world of Xamarin, native AOT has come to the equation. Now, of course, with that, there are limitations, and we've had many limitations that us as Xamarin developers over the years have had to, put up with or optimize in a few ways. But I do think that there are a few fundamental shifts in technology that require not only the app developer to move forward. I would say in .NET development in the last few years, there have been some fundamental big changes that have happened that I think require not only the app developer to make some changes, but also library developers to hopefully make changes too. And The ones I'm talking about are null safety. So actually, like that's kind of important. But then also with native AOT, there's also additional limitations. And Frank's like really wanted to
Yeah,
go here
I'm
with
dying.
it. He's dying to go for it. But so let me just break down the limitations because Frank has a lot to say on this topic. But with native AOT, there are certain things like dynamic loading. So like, assembly load file,
Yeah.
runtime code generation, like System.Reflection emit, C++ CLI interrupt, built COM support. It has to require trimming. This is a native AOT world that we're talking about. There's also issues with like single file compilations, and then just some other issues, even with like system link expressions, for example. So there's quite a few things that are happening, but between .NET 7 and .NET 8, there's been momentum moving forward, and that is really great to see. However, Frank and has some opinions on it, but I specifically want to talk about system reflection,
Yeah.
which is a big thing, or system even reflection emit, which is something. And you were telling me that you believe that this is one of the most important or more pillars of .NET, and I want you to
Yeah.
explain yourself because you had a small tweet fire with yourself about it.
Yeah. We can get into all of that. It requires a little bit going back and seeing the world as I see it, and how all these things. What is the definition of a runtime? What is the purpose of .NET? What is the purpose of reflection? Honestly, why do we use reflection? What use cases are we actually trying to solve with reflection? And I'll just say off the bat, I'm a big fan of reflection. I think it's one of the features that attracted me most to the .NET runtime. When we first started this podcast, we used to do episodes on like Frank explains compilers, and we're just going to talk about how do you make a programming language? What is a programming language? Like real fundamental stuff. And I would say like this is hitting it because native AOT with some of its limitations. One of its bigger limitations is they really don't want you using a lot of reflection. And we know this from the good old mono days because reflection requires a bit of a trick, honestly, from the compiler's perspective and the runtimes. They have to expose the code of your application in a way that the application can reason about its own code. That's weird, right? It's like a chicken and egg thing.
Mm-hmm.
And it's a fundamentally hard problem. Java never had reflection. Reflection is often something you only see in dynamic languages because dynamic languages can get away with it because they need all this runtime information so that they queue up things. You have very old programming languages like Lisp, where metaprogramming, programming programs that write programs. Whoa, what a concept! That was in vogue. That was thought to be the right way to code. In fact, only monkeys at typewriters should be writing real code. You should be thinking higher. Oh, what kind of code am I writing? This high level abstraction. Um, so without giving away everything that I just feel that reflection, code that can look at itself, reason about itself, let's call it consciousness, is a big feature. It's not a little feature. It's not a little tack on feature. It's not like, oh, I can also compile to JavaScript. I can run on the web. Those are cutesy little compiler tricks. Reflection is a fundamental technology. You see programming languages. Sorry, I'm thinking about Swift. Swift still hasn't adopted any kind of reflection mechanism. They're developing mirrors. Mirrors is another form of reflection. And you see all these languages that never were designed with reflection, and they're trying to kind of bolt it on. Whereas in .NET, we've had this beautiful world of, since day one, since .NET 1.0, all code could reason about itself. And so a program could say, yes, I'm supposed to pop up a dialog box here. And here's what's actually going to happen when I pop up that dialog box. Let's do some reasoning about it. Let's write an algorithm that thinks about what's actually going to happen here. It's a general concept called metaprogramming that I think is incredibly important. And with native AOT, it's becoming a little bit weaker. But we should maybe go back a little bit into the past of Mono and talk about even Mono didn't fully support reflection in the early days. So many, just so I'm not monopolizing all the time, let me bounce back to you real quick, James. What do
No,
you do you ever write, assembly get type? Do you find type? Do you activator dot create instance? Like, how much reflection do you use?
yeah, that was kind of like where I was going to go next, like where people see this. And I think there's two areas in which you see it, which is the area in which you write the code, or a library specifically that you're using is using it, because that's like how that type of functionality need to be implemented. There have definitely been parts in my life in which I've used some of those things that you have talked about. I've definitely looked at the types of applications. I've used like Mono Cecil, for example,
Mm-hmm.
and looking into different areas. I did this specifically. I mean, it's been a while since I did it. I forget if it was around different like game engine creation. I was creating different. I was trying to basically create my own little cross-platform UI
Yeah, buddy.
framework in a way, right? But then additionally,
Aren't we always?
yeah, if you're not creating a cross-platform UI framework every day, then who are you? The other area I was using it was in helper libraries a lot, because one thing that you're trying to do is get rid of some of the complications that people have around when to create new objects, how to create new objects.
Mm-hmm.
They want to avoid that. They want things to be very generic. So often what you're doing is you might be given a string, or you might be given a specific class, and then you're looking up the type, you're getting information, you're activating that. You want to bring those things together. And that's how you get some of the magic of um, very loosely coupled UIs and
Yes.
navigation and things like this together. So one of the only ways to get it, because you're literally passing someone a string, so you have to activate something. You have to go
Mm-hmm.
figure out what that thing is. I guess you could give things types and then do other things, but again, you're going to activate something at the end of the day. But I also did this. I can't remember when it was, but one of the use cases that I was using was, it wasn't even on my code, right? It was sort of like a modular based system where I was kind of plugging into another ecosystem. But it's like basically, if I was creating something and you were creating something, I would have to like load parts of your
Yeah.
code basically into the system and about it.
Yeah, and I do wonder. I would love to talk to some of the original .NET designers and ask them, why did they put reflection in. I know, as a programming language person, I know how I see reflection and
Mm,
what I think it's useful for. I would love to talk to the original devs and find out why was it included when other languages didn't bother. You know,
yeah.
because it's work. It's hard. It's hard to support reflection and things like that. And certainly the plugin model is kind of the obvious answer. You throw some DLLs in the directory when the app is starting up, reads a bunch of DLLs from that directory, dynamically loads them, does some craziness. Who knows what?
Yeah.
I think that's actually a fantastic use case. And you mentioned in the beginning, I think that's one of the limitations that comes with ahead of time compilation, is that you lose that ability to dynamically load assemblies, code.
Yep.
And you know, as a as an iOS developer for the last 10, 15 years, God knows how long I've been doing this, I've given up on that. I don't write plugin architectures anymore. My apps don't really support plugins. People still do it. IDEs still do it. It's still a very valid use case and all that stuff. But my own code, my own personal code, I just haven't felt any need for importing assemblies and all that stuff. And I think that's important to bring up because I'm about to spend the next 30 minutes making complaints about things you can't do with native AOT. But it's important to remember that this other big feature that was removed, this ability to dynamically load code, I don't have any problem with them removing it because I don't use it. Therefore, it doesn't affect me. Therefore, I don't care. And you could say that whole thing about what I'm about to complain about for the next little bit. If it doesn't affect you, you don't care, and you
Yeah.
shouldn't care. Honestly, it's a perspective thing. It's a use case thing. What I don't like is the narrowing of use cases. Just because reflection is great for creating plugins doesn't mean that's its only use case. It's usable in a lot of ways. So I like to think of reflection as higher level programming. Uh, I said any monkey can write a for loop. You do these things. But can you think abstractly about your code? What kind of classes should I create? What kind of procedures should I create? How should it connect to web services and things like that? Yes, you can sit down and write that code if you're a monkey, or you can think a little bit higher level and think, oh, what if I create a service description and then generate the code that needs to be done at runtime? What if someone gives me a function that I need to execute quite rapidly and the JIT isn't good enough? I mean, the JIT's wonderful, right? The JIT's great, but that doesn't mean it's perfect. Nothing's perfect in this world. And there are use cases where if you analyze the code, you can write a more optimal version of that code that has the hop path optimized for what you're doing. Not many people do that. Granted, I get it. Not everyone's a performance freak like I am, but it's the capability of doing that. It's that ability to think at a higher level that I really truly believe is important for a programmer to learn. If you're a programmer and you stop at my ability to program, you're never pushing yourself to think higher than that. Think, how would I write a program to write this program? And it's a little bit sad that that art is being lost a little bit. And I don't want to sound like an old man. Everyone should learn Unix and
Back in
learn
my
to write
day,
their own C compiler and
I
all
wrote
that.
everything in assembly. Ugh.
Right. So this isn't a machismo thing. Quite the opposite. I truly believe that we are at the wrong level of abstraction for programming. And we need to be at a higher level of abstraction. And you can only achieve those higher levels of abstraction with what we call metaprogramming, which is so derogatory. It's not metaprogramming, it's programming better. It's how we should be programming. Granted, our industry is only 50 years old. We're all honestly little children playing in a new playground that we don't know anything about. Can you imagine what programming is going to be in 300 years? It's going to be completely different.
Yeah.
We have no idea. And so we are primitive little apes creating boundaries that we don't know anything about. And I personally believe that we shouldn't build fences like that. I believe that we should stay at a very high level and keep pushing to be higher level. That kind of stuff.
Well, you know,
But let's talk.
I mean, I haven't been in school in a while, nor do I know how kids
Yeah.
are, or career switches are currently learning coding. But in the world of boot camps and the world of how software has changed over those 50 years, I do find it interesting to understand how people are learning and how they're exploring those things. Like one of the first classes that really kind of opened my mind a little bit about pluggable architecture was sort of this class that I had in college. It kind of bubbled down to like interface based type programming, but the whole idea was I have an interface called like iTank, right? And the tank can do these things. And the whole idea was being able to drop in two different assemblies that could load the thing from it. So it was like you create your tank, I create my tank, and we had this master program that you could pick two DLLs basically that would load it up, would open it up and would say, okay, hey, these two things implement iTank, and then they battle each other out. And you were trying to figure out your tank was trying to be the smartest of, I forget what whatever the grid system is of someone will write in whatever that thing is. But basically the whole idea is like who can, fire at the tank and do the query based system. So that was really the fascinating at the end of the point. But at the same time, I am intrigued today by excellent and astonishing code that is written for code that I could never write, but I'm intrigued by how it was written. I recently watched a video, and if I can find it, I will attempt to do it, but you can just YouTube it and put in disassembling Roller Coaster Tycoon. And Roller Coaster Tycoon is one of the best games ever created in humanity. We can argue about Star Wars versus Roller Coaster Tycoon. However, Roller Coaster Tycoon was written by one person, Chris Sawyer, and it was written in assembly. And if you look at the code and optimizing the code and how the code was written and how it loaded up all these submodules and all these random things from random files and optimized this code, Roller Coaster Tycoon ran on every single machine and runs on every single machine ever created. Basically, it is the most magical piece of software that I think has been written
Awesome.
ever, pretty much out there, especially in the game form, I would say. Besides, like, Space Pinball Cadet pinball,
Come on,
but
Doom.
and
Okay.
Doom, okay, and Doom.
Thank you.
But
Thank you. Thank you.
but when I watch somebody go through and actually like the disassemble, like the disassembling of it is like quite magical to watch, the debugging process going through stuff, but just looking at how the code was written and how it was architected and like this, Chris Orr was writing these algorithms to read things and parse things and put strings and do this stuff. And it was incredible, right? It's just really because back in the day, they had to optimize every little tiny piece. However, nowadays, Frank, I'm just saying we got a lot of processing power in the palm of our hands everywhere, right? So, again, when I think about, that thing intrigues me, but does that intrigue everybody? I don't know. You know what I mean? Or does people just want to write some code, jam on some things, stuff like that? Because when you talk about, oh, I want to do this, want to do this stuff, like, you're right. It doesn't really matter if it doesn't apply to you. And like you asked me earlier, like, how many times have you used it? Like, yeah, I probably have, but like, nowadays, no, it's been a while. You know what I mean? So that is something for sure that is, kind of top of mind for me.
Yeah. Yeah, it's tricky. When I say every programmer should strive to think at a higher level, I get it. Has turned into what I call technician work.
It's a job.
It's become skilled labor. Yeah, it's skilled labor at this point. And we don't need to think abstractly about everything. There's enough concrete problems to solve than to worry about abstract problems to solve. We don't need to make up new problems to solve and things like that. But anecdotes. Let's do some anecdotes here. So Scheme is a programming language. It's in the Lisp family. And Lisp has always had macros, ways to do metaprogramming, where you write a program that generates code that then the compiler either executes or compiles itself. There was a programming competition one year, and the competition was, here is a problem, make it as fast as possible. Classic, set the students free. Let's see what the students create. What does everyone do? If you're told to write a fast program, what does every beginner programmer do? They're like, oh, I'll write it in assembly. I will use low-level C code. I will use the Rust and the Go's and the dumbest language I can find because I know a dumb language will compile to simple code, and therefore I can comprehend the code that the compiler will generate, and therefore I can optimize the code that the compiler will generate. That's really what's happening in all these low-level languages. There was one student, however, that didn't do that. One student, a brilliant student, decided, no, I'm just going to focus on the algorithm first, because we all know your performance comes from the algorithm, not from the low-level code in general. So they decided to focus on the algorithmic aspect of solving this problem. Bashed at it in Scheme. Scheme is an interpreted language. It's not even compiled. So let alone any of the performance stuff. It's the slowest of slow, interpreted. This is Visual Basic territory we're talking about here. This is Python. Every language you've ever made fun of, we're in that territory right now. You know who won that competition? The Scheme program. Do you know why the Scheme program won? Not because Scheme is fast, because they spent their time writing the algorithm as they saw as best they could in Scheme, using a nice high-level language, something safe, something comfortable where they could experiment with and play around with. And then, when the algorithm seemed half decent, they wrote a tiny bit more Scheme code that blurted out, I almost said a dirtier word there, that outputted just a bunch of C code that then implemented the algorithm in the most memory-efficient way, the most CPU-efficient way. That's metaprogramming. I used a higher level language to output lower level code to solve a problem that I have. Metaprogramming.
Yeah,
that's what that is.
It's very similar. When I was at the game studio, for example, we might have mentioned this before, but one thing that I ended up doing is I created this WinForms application that was like my Pinnacle WinForms app. It was a particle tool, and the whole idea was that in a video game, there's tons of particles and compositions of particles together. Think about an explosion, right? Let's say you have an asteroid. you're exploding it. Well, it goes into multiple pieces. There's layers on top of it. There's fire, there's smoke. They need to have all different aspects to it. So the whole idea was you would load up different models. And you can basically create a timeline. Basically create like a video editor, but for particles. And
Yeah.
then every single particle was in a list. And then you could go and every single particle had a list of properties that you could modify, because that's what like the shaders or just like the engine could handle at that time. So we're thinking like rotation, size increase, decay, right? Like decay would be like it goes from this size down to 0 over so many time, and then it's rotating at this speed, and it's random, is at XYZ. So then the designers could implement and see it right in real time. So what ended up happening at this form of it is that as the designers were using this tool, I would have them save the file out. So like, I don't know, I forget how I saved it, maybe in a XML file or something like that. But like, here's the dump basically. And then I would load it up on my machine and I'd take a look at it. Now, at this point, I need to go insert it into the engine. So what I wrote was code that wrote code in C++,
Yes.
right? So I'm over in C#. So my particle tool spit out pixel perfect C++ code that I could then directly just put into the game engine and will load up everything 100%. So it basically was a program that the designers could use that would then export codes. I didn't have to write the code in general. And that was like kind of a game changer. So the productivity loop became quite brilliant at that point.
Yeah, James, now let me blow your mind here. What if the programming language you're using to write that high-level code could output not even code, because that's sloppy, text files and compilers, that's gross.
True.
What if it could just output the actual code it needs to execute and then just executes that code?
Yeah.
Wouldn't that be awesome? And yes, I'll just answer for you. Yes, Frank, that is awesome.
Yes, Frank, that was.
And it's a very powerful and interesting feature. It's honestly one of the reasons that drew me to .NET. There were multiple things that drew me to .NET. A big one was it was multi-language. I've always been a multi-language person. But the other one was I was a Lisp programmer. I was a meta programmer. I believed all programs should be written at a higher level than we write them today.
Yeah.
And so I was tired of, yes, okay, so I can write a program that outputs C++ code, but then I still have to write the C++ compiler. Wouldn't it be neat if there was a library I could just say, here's the code, turn it into something executable, start executing it.
Yeah.
Yeah, and that's what reflection is. That's all it is. It's just that level of metaprogramming. And so I see it as a truly important feature of any language that I'm going to use, basically. I'll just put it that way. Because it's a mindset. It's a way my mind works. It's the way I think about programs. I always think about programs in terms of programs that can program themselves. I've always thought about code that way. So it's a tricky thing, because even when we first started out in iOS and Xamarin and the original Mono Touch days, reflection didn't work. Of course it didn't work. Generics didn't work. Async and await didn't exist, and certainly didn't work because they didn't exist at the time.
Sure.
And so there were tons of limitations. So are they necessary features of a programming language? Absolutely not. No way. I can write a I can write a program in any language to output C# code that then the C# compiler can then compile and mix in, do whatever. So it was more of a elegance feature, a beauty thing, a sophistication of a runtime that it internally could generate code that it could then execute. Again, all the dynamic languages do this. It was really cool that we had a JITted, but compiled language that could also do it in .NET, and also cross-platform, and also cross-language. We don't give that enough credit. And I know not everyone thinks, Frank, not all of us are F# programmers. Well, there are other programming languages than F#. There's Python, there's JavaScript, there's BASIC. There's C#, there's C. There's many languages out there, all that can very, very well run on .NET. And what if all of a sudden my Pascal apps could do metaprogramming? What if my BASIC apps could do metaprogramming? So it was this really clever thing in .NET to enable any programming language to do metaprogramming, which again is a very niche thing, but
Yeah.
is a mindset and was the exclusive territory of more academic languages previously. This was bringing an academic concept into industry, really.
Yeah. Well, let's talk about a few things first. The first thing, I have two specific categories I want to talk about. And first is like performance. Because I think often when people think of system reflection or system reflection emit or anything in that namespace in general, they think about that, hey, that's going to have performance overhead, right? And that's often what you hear is like, well, why would you use system reflection if you're trying to create a native AOT app, which is supposed to be fast, and system reflection or system reflection emit or any of these things are slow,
Mm-hmm,
right?
mm-hmm. I'd say slow is relative. People keep saying slow, but define your terms, everyone. It's not slow. It's actually quite fast. Um, Newing up an object in .NET is slow, in my opinion. Calling a function in .NET is slow, in my opinion. These are little costs that we accept as programmers for the other benefits, for amazing tooling, for great library access, for great programming language access. We all accept these little performance hits. So is there a performance hit when you use system reflection? Absolutely. Oftentimes you can greatly outweigh that tiny performance hit with a huge performance bump by being able to write tailor-made code for that system. Now, on operating systems like iOS, obviously, thanks Apple, you cannot generate code at runtime. Apple threw down the hammer, we should all say,
Mm-hmm.
by the way,
Yeah.
in iPhone. Apple said, metaprogramming, nerds, go away. So, from Apple's perspective, metaprogramming is not important. They don't care. They don't care. But just because a large corporation in America doesn't think that a programming concept is important doesn't mean that that programming concept isn't important. That's just how it is. And so we all accepted that in order to make reflection work, because Mono ran on iOS and it did support reflection eventually. It took a little time because it's hard. It's hard to
It's hard.
support a
Yeah.
sophisticated feature like this. They had to do tricks, and for the longest time, we had support for reflection in the terms that the code could look at itself. That's one half of reflection. Can I write code that can then reason about itself? That's
Mm-hmm.
a good half. Okay. The other half is, can it then generate new code to be executed and run? So for the longest time on iOS with AOT compilation, we only had the first bin. Code could look at itself, and it could but couldn't write executable code. At some point in time, I forget, .NET 3, 4-ish, we got System.Link. Everyone loves System.Link.
Mm-hmm.
But not everyone likes it for the right reasons, can I say, James? A lot of people miss the fact that expression.link really, or system.link, I gave away the thing there, gave us the expression class. And this was our first little step into formal metaprogramming in the .NET library. So now we have .NET that supports reflection and metaprogramming, but now we have a library built on and designed for reflection, this expression class. Anytime you write a programming language or a compiler or something, you always start with your expression class. It's the thing that does stuff. It's the thing that does computations. It calls functions. It does very basic if statements and things like that. We were given system.link and we were given expressions, and they're very important. Everyone loves link. Everyone wants to use link. We use link for everything. And so in order to do that, Mono and any other AOT thing would have to run an interpreter, because you are now generating code at runtime. Great, fine. .NET supports that. But if you're on an operating system like iOS, you are not allowed to do that. That is not allowed. And so we would run an interpreter to do all of the nastiness to make what should not be executable.
Yeah.
And that's why we get this annoying performance hit from .NET.
Okay, so Frank, when I think about this in the fact of that System.Reflection is doing a lot of things. There are some reasons in which it is slow. What if instead of figuring out how to run code at runtime and do this, what if we did it ahead of time, like ahead of time compilation?
I
Ahead
see what you did.
of time, automatically, I don't know, generated that source code that you were trying to do, source generation, and then you could compile that source generation.
Mm.
And then, for example, it would run lickety split super fast.
Yeah. Okay. I see what you did there. You tried to circle around me and hit me from the back. No, it's not going to work, James. It's not going to work. Because I knew this was coming, and I created a defense earlier on in
Oh
this
gosh.
game. I said there's always a primitive way to do metaprogramming. You just write a program that generates code.
Yep.
It's trivial. Any program can output a text file. I think one of the greatest epiphanies I had as a programmer occurred while I was staring at a progress bar. I was writing some C code. I was uploading it to a car, and by uploading it to a car, I mean I was burning an EEPROM, physically burning new transistor pathways into
Whoa.
a programmable logic chip. And it was slow. It was very slow. It gave you a lot of time to just look at assembly code, or not even assembly code, just the hex bytes of what you were transferring over to that chip. And it occurred to me one day, I'm like, so all this clever C code I wrote, all my cleverness really just boils down to a bunch of numbers in a file that can be represented in hex. And those just get put on a chip and then uploaded to a thing. And it was a wonderful epiphany when I just realized if I could write anything that generated the right numbers in the right order, I could make anything do anything. And that was my great, oh, that's how compilers work, epiphany of my early programming career. So, yes, as programmers, we can obviously write any program that generates any other program. Do it today, right now, while you're listening to this podcast in C#. Go output some C code just for fun. Who cares? Who cares what it even does? You have now just graduated to a meta programmer. Bravo, congratulations. You have honestly stepped up one level in your career. But that's inelegant trash, okay? It is much cooler if at runtime you can play that same game. If that game is baked into the language itself. It's baked into some languages. C and C++ have macros, which people deride all the time, but they're powerful. They're powerful as F. And you can do lots of metaprogramming with them. Template metaprogramming that you can do in C++. For years, it was derided. Now you can't download a C++ library that doesn't use metaprogramming because they finally baked metaprogramming into C++. So absolutely, any programming language has always been able to source generate code for itself, other languages, anything. Any program can obviously generate code for something else. So the solution, I'm sorry, we're going about this in a roundabout way a bit, but a very simple solution to native AOT not supporting reflection is, man, just write that code to output some code. It's no big deal. Then you compile it and it all works. And I agree with you, James. You're absolutely right. That is metaprogramming. That does solve probably 90% of the use cases out there. But you're going back basically 50 years in programming. You no longer have an elegant, beautiful solution to a problem. You have a solution to the problem that any language can do, any runtime can do, any compiler can handle. It's not interesting. It's not powerful. It's not fascinating. I'm sorry, I take that back. It's incredibly powerful. Of course, it's powerful. It's not interesting. It's not integrated. It's not cohesive. It's not a part of the language. And I think that's a big loss. We'll just say a loss. Elegance is important.
Well,
beauty is important.
There's a few things. Like one, there's been folks that have been attempting to do and figure out this solution as far as it goes with performance for a long time, right? I think we saw this early on with Fody, for example, and doing IL weaving. to handle like complex view models. More
Right.
recently, we saw the introduction of source generators, which is like,
Yeah.
hey, you want to actually see these types when you're coding. If you IO weave,
Mm-hmm.
you see them after there.
Yeah.
What if we could source
Yeah.
generate these? We get them there.
Improve the
Now,
tooling is what
improve the
that really
tooling.
means. Yeah.
Improve the tooling. Yes, exactly. Improve the tooling, made it more standardized, and help more people do that up front and handle that there. Now, those are often, I would say, the more mainstream of what people need to do in this world. Whereas it sounds like what you're saying is like, yes, there's more niche cases, which are important, right? And they
Mm-hmm.
should be used, but it's not maybe general use case that are out there.
Yeah.
However, there are, for example, a lot of libraries under the hood that might be doing this today that are important. Because if you remember in Native AOT world, like to Native AOT, if you're using a library that's using reflection, then that's also
Mm-hmm.
going to have issues too. So the real
Yeah.
question comes down to this, right? Do we rewrite, sacrifice, do some things? And there's a great blog post on the .NET blog about this, about how some of the libraries have gone about optimizing themselves for
Right.
native OT today, or because it's a limitation today, doesn't mean it's a limitation
Yeah.
forever, right? It doesn't, right? It's the,
Right to your Microsoft representative.
yeah. Then what does it look like, right? And this is sort of the same world that we've had for a long time. As .NET evolves, when
Mm-hmm.
do folks jump on the train for the greater good of things, right? We think about this like net
Yeah.
standard libraries, right? For example, like,
Yeah.
okay, like, hey, we all gotta take this, we gotta do this because everybody wants to use this library, not just .NET framework applications, right? So there's that sort of aspect of it as well, is like, when do we decide to like opt in, jump in on these things that are
Yeah.
out there, right? So it's something to think about in general. But there's a great blog post kind of talking about how you could specifically do some native AOT
Yeah.
compilation hacks, if you will, to get your code up and running and better. And there's source analyzers and things like that as well that help you out too. But like I said, it's a current limitation, right? Doesn't mean it's always
Right.
a limitation. We saw in the world of Xamarin
Mono.
and
Yeah.
Mono, right? That eventually, things eventually came around. I don't think you ever got 100%, but you got pretty
It's
dang
100%.
close. Is it 100% now?
Yeah, when they introduced the interpreter,
Yeah.
that's what it took.
Yeah.
It took a full language interpreter, runtime interpreter, to
Oh.
make 100% reflection work.
Oh.
And okay,
Yeah.
this is actually a great place where I kind of want to end my argument.
Okay.
You're absolutely right. A current limitation of native AOT is that it doesn't support reflection emit. Fine, we didn't have it in Xamarin for years, honestly. And I will admit, source generators are very cool. In an AOT world where you cannot dynamically generate and execute code, they are more performant. They're cool.
Yeah.
I have my gripes about them, though. They're C# specific. To me, .NET is still a multi-language platform. I don't care that C# is the most popular language on it. I've always considered .NET a multi-platform language, and that's how I use it. I use multiple languages with .NET. And so Nito, glad it helps you all C# programmers out there, but .NET is more than C#, and it will always be, and I will die on that hill for sure.
No, I hear you.
Yeah, and there's the kicker though. Okay, so source generators, they are fine. I do think it's good to have source generators. They are filling in a very important need, especially for libraries like SQLite. SQLite-net could 100% take advantage of source generators because 99% of SQLite.net users are using C#, and therefore source generators will work out absolutely just fine. Great, wonderful.
Yeah.
But this is a limitation. A .NET platform has reflection. And we know that native AOT can run reflection emit. I'll tell you why. Because my apps do it. Continuous, my IDE, has an interpreter that I, Frank Krueger, wrote that runs in an AOT environment. I do not rely on reflection emit. I do not rely on any. Okay, I take that. I rely on some reflection. Throw that part out. Technically, I don't have to. But you can write today native AOT code that can interpret IL code, .NET code, and run just fine on any native AOT platform. So the fact that it's a limitation of native AOT is a really artificial limitation. And I think one of the things that makes me a little bit angry is that it is an artificial limitation. It's just no one thinks that the feature is important enough right now to do the hard work of making it work in the AOT scenario. It does work in AOT. It just requires that you write a tiny little interpreter. And interpreters are fine. Python's an interpreted language and it's incredibly powerful. JavaScript is an interpreted language. It's incredibly powerful. Just because you want compile time type analysis does not mean you should give up interpreters. These are two different things solving two different problems. You can compile ahead of time and still interpret code. It's fine, everyone. Get over it. And so I think my biggest frustration with native AOT is that we struggled for so many years to finally get full reflection in the mono Xamarin world, and we did get it. We got it. And then we're reset all the way back to 2010 with native AOT with this artificial limitation that does not need to be there. They can write an interpreter. They can write an interpreter that does all of this stuff, all the stuff that Mono did, all the stuff that Xamarin ever did. It can be done. Microsoft programmers are very brilliant people. They can do it. So this is an artificial limitation put on by classic economics, supply, demand, all that garbage, things I don't care about. And so what I see is an artificial limitation coming on my beautiful, gorgeous .NET runtime, and it frustrates me. I have code on my computer that can run reflection emit code on native AOT. I know it can be done because I've written code that can do it. And therefore, I just find it very frustrating that source generators are told, or that we're all told, just do everything with a source generator. Instead of solving a hard problem and making everyone's lives better, Microsoft is saying, everyone change your code to make our lives easier. And I think that's the one that kind of pisses me off a little bit.
Well, I think like anything, it all comes down to prioritization and engineering resources at the end of the day. But, Frank, it is open source. You go write the feature, Frank. Put it in there.
It's in mono. I have to learn how the GitHub repos work. Like, there is a gorgeous interpreter sitting there in mono that is battle tested and proven. That works just fine.
No, I understand what you're saying, though. I understand where you're coming from, and this is just like anything, right? It's like, again, when something is important to you, right, and that you obviously will be more passionate about it. So it makes sense, which is why it's kind of good to analyze the background of system reflection and just reflection in general, how it works, how other languages use it, what don't enable it, right? Why there are these limitations, where we're at today, where we're going in the future, and why to some people it's very important and why to other people it's maybe not as important.
Right.
But even if it's not important to that person, underlying under the platform, there may be other implications that make it important to you as an app developer. So it's kind of important to break down those aspects. And like I said, I'll put a link to the blog. It is a great blog by Eric, which is really fantastic. So I'm excited to see how it evolves, because if you remember this time last year, we were talking about how excited we were that native AOT applications for console could be like it could be fit on a floppy disk, if you remember, because they're so small. I will say that something is really fascinating to me, because I'm always used to, like, in the world of normal AOT, that usually when I AOT my application, they get bigger, but it seems like with native AOT, get smaller, which is fantastic, somehow magical, different technology. So that might be a deeper analysis for another day. But I am excited to see how this new native AOT stuff plays with iOS and tvOS and Android as well, since they are coming out. They're new technology. So with any new technology, there's points, Frank. I know you want everything on day one, but you don't get everything on day one. So we'll see. But
I already have it. Xamarin still exists right now.
Yeah, you still have it for you. You got it. You're good. So, well, I appreciate you breaking down and talking through your box of soap that's in there. So we'll put this soap back in the box, ship it off until .NET 9, and come back and reanalyze it then. How does that sound, Frank?
Yeah, in the meantime, I'm just going to release a NuGet that has an interpreter in it, and it's going to be native AOT compatible, so whatever.
Problem solved. What you heard here first on Merge Conflict is Frank is going to solve all of your native AOT problems. But that's going to do it for this week's Merge Conflict. So until next time, I'm James Montemagno.
And I'm Frank Kruger. Thanks for watching and listening.
Peace.